Hello, ladies and gentlemen, and welcome back. Welcome back. We're looking at question 12 now on the 2007 Fermat paper. In the diagram, PQ is equal to 10, and hey, they have that labeled for us. QR is equal to X. The value of X is. Alright, so we got a little to unpack here. We got a 90-degree angle. That's pretty important. I'm noticing some 30s and 60s. Oh, isn't that wonderful? I'm sensing some 30, 60, 90 triangles coming along. Okay? And I can see right away, well, we've got this 60 here. Some of the angles in PQS has got to be equal to 180 degrees. So that's going to put a 30 down here. And look at that. This whole angle here at S is 60 degrees, and that pairs up nicely with this 30 and everything. Okay. So these 30, 60, 90 triangles, well, if we've never seen them before, what are you talking about? Well, we'll just get ourselves a fresh piece of paper. 30, 60, 90 triangles are a type of right angle triangle that come up a lot, especially on math contests and also just in real life. I mean, I can't even tell you how many questions I've done in first year calculus with some of my students where, you know, we've used special angles like 30, 60, and 90 before. So it's a nice right angle triangle. 30 and 60 are wonderful angles. They're nice integer angles. They're also nice when you convert to radians. They're just wonderful. And the sides of a right angle triangle, no matter what the sides are always in the same ratio. Whatever's opposite the 30, you double that to get the hypotenuse. So 1 to 2, already that's wonderful. And then you can do Pythagoras, however, or whatever you want, and you'll get a root 3. So it's 1 to root 3 to 2. So if on this side I had, say, 10, well, then over here, I'd have 10 times root 3. And what's twice 10? It's 20 for the hypotenuse. We could do that again, 100. Well, you get 100 root 3, 200, that sort of a thing. It's very wonderful. They pop up all the time on contests, and it's something that you should do your best to get accustomed to. And if you didn't know this before, and you sat at this question, you said, well, it's a grade 11 question, so I guess they expect me to know trigonometry, and you're grabbing your calculator, and you're doing your sines and your cosines, you're going to see, 0.5, and you'll think, great, a half. But you also see this, 0.866, and, it's not really going to enter into your brain as to why that's important. Instead of trying to do it just with a calculator and sines and cosines, stop for a moment. If you didn't already know about 30, 60, 90 triangles, try and redo the question, not with any trigonometry, just knowing that the sides have ratios 1 to root 3 to 2, and try and do this as sort of a giant similar triangles question. Okay, pause the video and try that. Done? Okay, great, because it's important to get practice with these sorts of questions when you can, and I can't really give you a list of, oh gee, the Cayley on the 2009 paper has one of these as question 12 or anything. I can't say that off the top of my head, so I figured, why not just pause the video and try it now. So we have 10, and we want this X. I think it was P, Q, S is here, R is here, 30 degrees here, 60 degrees here, a full 60 degrees here, but broken down into two 30s. Okay, and you could certainly do this question completely ignorant of these ratios. Okay, it's absolutely a triggable question. But, we put this 10 here. Suddenly, okay, what's opposite the 60? 10 root 3, just in sort of this 30, 60, 90 triangle. Okay, but then, well, we've got a bigger one. We use green. And now my 10 root 3 that I just figured out is opposite this 30. And what's opposite the 60 down here? 10 plus x. And so that's going to be 10 root 3 times root 3. 2 root 3s, that's just a 3, so this is 30. X isn't 30, but the whole side, PR, is equal to 30. But PR is PQ plus QR. And I think we can all see from there, X is going to be 20. Okay, so 20 is our answer, and I didn't have to do any trig beyond knowing this triangle right here, this 30, 60, 90 triangle. And yeah, I know this video's taken a little long, and usually question number 11, 12, 13, these are all done a little faster on the Fermat paper. But, you know, we stopped and said, do you know this triangle? If you don't, try the question this way. But let's get back to it. There it is, 20, so that's B. And there we go. We finished off our question, and that was question number 12. Up next will be question number 13. It looks like there might be a little three-dimensional geometry, but we will find out about that when we get to it. If you haven't tried question number 13, feel free to give it a try before you watch the next video. As always, feel free to like, subscribe, give a comment if you did the question a different way. And until the next video, take care.